Okay, I'm going to give a little tour of this toy AI agent. It is effectively the same kind of thing as you get from Cloud Code or Open Code or Gemini CLI or Codex. So if I launch it here, it's just giving me a REPL. I can, of course, enter things into it. So let's say, what is the temperature in Paris right now? And I don't even know how it's going to answer this, but it will spit out an answer at us here in just a moment. The idea behind a question like this, though, is it has to use tools, right? The LLM does not know anything about right now, but of course it still gave us the weather for that. Okay, so one of the things you'll notice here is, that it is tracking the elapsed time while it's running. You're seeing session spend and token usage. The token usage is actually being calculated wrong. There is a bug in it. That is one of the things that I'm going to be working on next. But one of the reasons I built this, of course, was to experiment with tools and how it works behind the scenes. So if I turn debug on and I say, we'll be able to see what happened just now. What is the temperature? Actually, I'm going to do this. I'll explain. It's kind of dumb, but one of the things I have going on is there's a pipeline to every request. And one of the first things, just to demonstrate the pipeline, is that it actually will fix the spelling. So you'll notice that we had what is the temperature, but what it does is before it sends it to the actual model to ask the question, it actually does fix the spelling. Now we can see a little bit of what's going on here. It obviously created and executed a bash script to be able to get the answers. Those messages from both the spell check and the execution of the bash script were redacted. They're marked as redacted. They're not useful to the context. What's useful to the context is the eventual answer, which is London. And so that actually ends up in the context. Interesting. We're seeing a bug. Oh, no, we're not seeing a bug. For a second there, I thought we were. It was because I had this highlighted. But it gives us the actual answer, and then like it's supposed to, it gives us the token spend. And what it's telling us here is some of the pieces that happened on this cycle were needed. They needed to exist during this prompt. But as soon as the answer was given, they're no longer needed. And so now it's even marking even more stuff redacted. This is what keeps the context window really small. Quite truthfully, it's not that much different than what happens with other agents today. Basically, like Cloud Code would have just marked all this tool usage as not useful and not passed it into the context. But we can go even further. I can make sure I get the right command here. It's verbosity, and we can set that up higher. And now if I ask it, what is the temperature in, I don't know, Atlanta? We'll be able to see exactly all the details of what it was doing. So again, it corrects the spelling. And then it actually, so now we can see the bash script that it's executing this time. It's just a small bash script. It's just a curl get from some website, the weather.in website, and then it spits back out the answer, right? So let's do something a little bit more complex. Well, first, let's do, let's show one of the things that I know what I want to show. Tools. So this command lists the available tools to the agent that the LLM can use, right? That the model can use. These really aren't particularly useful to us. They're for the model to use. But what you can see when you are up here is you can see it use the execute bash tool, which is right here. It actually used one of the tools we provided. Let's make it use a bunch of tools. So let's say I'm running this from the directory that is the source code for NuAgent. So if I say, please summarize the okay, so we have the verbosity turned up. We're going to see a lot of stuff here. We have the verbosity turned up, and I'm asking it, hey, go take a look at the code on the hard drive and give us a summary of what's going on. First thing to do, of course, is still do that spell check. The spell check isn't really useful. The LLM would be just fine giving it the misspelled stuff. It's more of a demonstration that I can stick a piece of code in the pipeline of processing a message to modify the message. That was its purpose. Okay, so let's take a look at what it's doing here. So first is spell check. Now it says, hey, what are all the full file, or what are the directory tree look like? What are the, do you see these particular files? This is really kind of inefficient because, I mean, it could, so what it does is, I'm a little perplexed on exactly what tools it's choosing to use when, right? Why it's making separate calls. This one makes sense. Well, the README makes sense because if I'm in a project, I can read the README and then I can get a whole bunch of information. And the first thing it does is assume that it's in a node JSON project. And then it says, well, if I'm not in that, maybe I'm in a Python project. Well, if I'm not in that, let's look for this. And then eventually it says, hey, if finally probably, I don't know why it figured it out, but it said, oh, okay, is there a gem file? Yes, there's a gem file. And then it also looked for a Docker file. So these are just the things that the LLM automatically looks for, trying to discern stuff about its environment. I didn't pick it. It picked it. But it decided to use the tools that we provided it. So that's the important thing. So now if you look, we start getting the actual results from these. So part of what's going on here is it's spitting a whole bunch of tool calls at us. And then more sophisticated agents than this can pipeline the answers, right? So it's effectively saying, hey, it wants to be able to give, I'm sure what's going on is it wants to be able to give us a whole series of calls and do it all in one exchange where because this is a simplistic learning project at this point, it's still doing it one at a time in a loop. But what we do is we start running these things, and you can see that we do the directory tree, we look at all these things. It actually gets to the point of looking for more files. Eventually, it's reading the files. Okay, it says finally, and now it's going to read the README. And we actually see the contents of what's being sent back there. Summaries, more token spend, et cetera, et cetera, et cetera, right? And so it looks at a whole bunch of files, and then eventually it spits out, here's a concise summary of the project in the working directory, high level, blah, 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 blah. Okay, that's a pretty good demonstration of it using its tools, but it also can, so let's look at this again. It also can actually look into its own database. So if I say, so it's going to do the tool usage to actually go look in its database. And I've actually had it get in quite recursive kind of situations where I'm trying to use this to do debugging. And the debugging was about the history. And every time it tried to go debugging, it would put more messages in the database, and it would confuse itself because it wouldn't have the answers that it wanted. So it kind of had these little inception moments. It was interesting watching the LLM kind of trying to deal with this. That is part of the experiment that I'm doing with this, which is to let it inspect its own memory, let it be self-aware of its own state. That is not a correct answer. I mean, you can even see it right here. What the heck? I'm trying to figure out what it did to get the wrong answer. That will be some. So here it's selecting where this conversation ID, where the current conversation, limit one. I do not know where redacted equals true. They're almost certain. There has to be, because that we actually can see that there are 36 marked as redacted just from this conversation above. Let's see what it does if I challenge it. Why did that query, though, return I do not know why it gave the wrong answer, but we're going to let it have a chance at spitting out the right answer here. What is it that I also want to show? There's not much to show here. I mean, it is just an AI agent with a bunch of tools that it can use. I think I do actually know what I want to show. I want to kind of jump over, and you can see how some of the pieces are structured. But I don't want to wait forever, so let's cancel that one. So another command that I have here is info. I can see certain things, like the state of things. Debug is on, verbosity is true. There is this concept of conversations and summaries that is not really being used yet. I kind of was in another fork of the code, but in this particular one, it's not. Here you can see that the spell checker is on, and then the GPT-5 Nano is the agent, is the model I'm using for it. So I can say spell check off. And now, if I ask it more questions, of course, what is the time in? There we go. Nice little. So every now and then we still get errors. Normally I would just start debugging this right inside of the agent, but we're making a video, so I won't. And must be. Yeah, it's hard. Yeah, I'm not going to try and debug that right now. Clearly, it is an assistant message with tool calls must be followed by tool message responding to each tool call ID. An assistant message with tool calls. So the tool call must be followed by tool messages responding. So it redacted something. It didn't send something that it should have. That's fine. Anyway, you get the idea. It's a working agent. But let's take a look so you can kind of see this. So in terms of clients, I support a number of clients. If we just look at one of these, each of the clients has its own system prompt that it gets that's specific to it. Basically has a little pricing information and how big the context window is, and it loads an API key. But it's a really simple library, simple class. It sends a message. There's a bunch of stuff in here about extracting redacted stuff from the messages that it's sending, and then some basic stuff about identity and whatnot. They're not particularly complicated, and they're all almost identical. Now, if we look at a little bit deeper, if we look in the tools folder, you can see this is how all the tools are provided. So if you were to jump over and say, look at the file glob, let's take a different one. So let's do directory tree. What you can see is it has to be able to return its name. It has to be able to provide the description, which is given to the LLM. The way this works is the way the code works is every single time it's going to send a message, right? These are stateless. So what it has to do is it has to obviously send the question, but it also is sending the entire history of the conversation. But what we're doing here is we build up the history of the conversation, but we redact a bunch of stuff from it if it's not relevant. Then we wrap, or then the next thing that comes in, just before the question is actually all the tool descriptions. They're actually sent every single time. So, we're only sending the first sentence. In fact, what we're sending is effectively the same as what we get when we say tools here. So this is what we send to the model, and we say, hey, these are the tools that you know that you can use. And it knows, it's actually getting the long description of these. So when we go back and if we go back and look here at the tools, and let's say we take directory delete this time, what was being shown on the screen a second ago is the first sentence of this, but this entire description is what's sent to the LLM. And then it's also sent this information. And what this is a sort of a schema by which it can talk back, right? So what we're saying here is, well, you have to send a path parameter. Well, there is such a thing as a path parameter. It is required. You must send it to us. It is of type string. And this is just a plain English description of what should be put in that string by the LLM. And then there is a parameter called confirm delete, which is of type Boolean, has this description, and is not required. It does this thing for, we describe it in the description here. So on the first call, it's giving us, that's interesting that we're letting it do the confirmation. That's what you get when you vibe code these things. But effectively what it's doing is it's calling us once with that being false. And then depending on what we respond to, it would call it again with true. That's probably not the best way to do it. But you can see what happens then is eventually we receive a tool call, and it calls the execute function in here with the arguments that were given, as well as the history and context. This is the context being built. This is literally a class that wraps the database. Again, this is largely vibe coded. So because I'm going to be iterating and creating a I don't know what we're on now, V4, V5, V6, a couple more versions will get created. Once I get the basic structure of the program, then I am going to take the time to build something that is that has a higher code quality. Right now, functioning is all I need because I'm experimenting pretty broadly. Anyway, that's what a tool looks like. It's pretty straightforward. Trying to think if there's anything else that's worth showing. Not really. So that's the deal. Adios.